Hello, I'm Suhail and today I'll be demonstrating Relic, a system for retrospective lineage inference of data workflows. Consider a scenario in which you've just recovered some files from a data lake, and you've started the process of sifting through these recovered files. You would like to know how these artifacts relate to one another. Furthermore, you can assume that timestamps and other metadata that's provided by the file system may be unreliable, so you have to rely solely on the contents of these files to make sense of how they evolved from each other. If we know that the files are somehow related to one another through some data workflow, what we want is a way to construct a tree or a derivation graph that allows us to make sense of these files. More formally, is there a way to construct a tree that most closely represents the true derivation of the artifacts from one another as measured by the edge F1 score when compared to the ground truth? Our system Relic does just that. We use various similarity metrics to hypothesize the relationship of these artifacts, assuming that artifacts that are more similar to one another are more likely to have been derived from one another. Our system constructs a derivation tree in stages. We first cluster all of our artifacts by schema. We then find relationships that involve fine-grained changes to artifacts such as cell-level edits or other row-column operations using Jaccard similarity and containment scores applied to individual table values. For more complex operations, we have designed operation-specific detectors that use value set containment at specific locations of the table to find join, group by, and pivot operations. Additional detectors may be designed for other operations or UDFs and is left as future work. Let's take a look at Relic in action.
For user input, I have 7 CSV files belonging to a single data analysis workflow zipped in this file. If we unzip this file and inspect the individual artifacts, we can see that there are a few synthetically generated tables that have been modified using pandas operations. I also have a ground truth annotation for this workflow. The ground truth shows the source and destination edges in the actual ground truth, which was used to generate that workflow, as well as some data indicating what operation was used to go from the source to the destination and some of its parameters. Feeding these into Relic, the user also has an option to toggle some parameters, such as whether Relic should first cluster the artifacts by schema and then start by adding those edges to the workflow or not, as well as the different types of similarity scores and detectors to be used in Relic. Furthermore, the user can set edge retention thresholds for similarity scores for artifacts that go between artifacts in a cluster and across clusters. Once we click the Infer Lineage button, our zip file and ground truth are uploaded to the Relic system, which then computes the pairwise scores, runs the detectors, and gradually builds the graph. The UI will then render the graph for us. This graph is interactive. The user can click and drag the graph to view various parts of the graph, as well as click to reposition nodes and explore the graph. The user can also click on any node at any time to inspect the artifact that is represented by that node. In this artifact inspector, the individual tables can be inspected along with sorting and searching capabilities. You can also open up the legend. Green edges are edges that Relic inferred correctly vis-a-vis the ground truth and are thus true positive edges. Red edges are false positive edges in where Relic inferred the edge incorrectly with respect to the ground truth. A black edge with an X is a false negative edge which Relic missed, as this edge was in the ground truth but was not inferred by Relic. In case Relic is used without ground truth annotation or clustering, you will be provided with a simple graph without any node coloring or edge coloring. Node coloring in this graph denotes the artifacts that belong to the same cluster. We have a few CAN demos as well, some of which are crawled Jupyter notebooks from GitHub as well as Azure ML. As we can see, Relic demonstrates reasonably good performance in finding lineage for many of these workflows. We also have a synthetic workflow consisting of 50 plus artifacts with about 5 or so edges which Relic inferred incorrectly.
Let's wrap up this demo with a few key takeaways. The Relic system just demonstrated can infer the lineage of tabular data artifacts retrospectively. The system uses fine-grained similarity metrics and coarser detectors to find relationships between artifacts and produces a lineage tree. We believe that this tool can be used for data lake organization, forensic analysis, and other downstream data activities. Thank you for your interest. I'm ready to take any questions.